We are evaluating this integral, the iterated integral of y times cosine of xy over this region, which actually represents the volume under this surface over this rectangular region. Okay, so that means that we have, so this is the function y times, or the surface y times cosine of x plus y, and here we have 0, 0, and here I have pi over 6, 0, and on this side I have 0, pi over 3, 0 actually, and 0 here as well. I'm including a live script of this MATLAB graphing with the video. So what we are going to do is that when we integrate this in over this domain, I am thinking it may be better to integrate with respect to with respect to x first, because that will keep the integration with respect to y, the integration by parts, easier. Okay, so now coming back, since we decided to integrate with respect to x first, so what we have is we are going to go in this order. So we have the limits for x written here and those for y over here. Now, so first we are going to integrate this, by the procedure of our iterated integrals, by treating y as a constant. So if y is a constant, then the antiderivative of cosine of x plus y will be what? Simply sine of x plus y, right? So we have this integral right here, right? And then we will have y sine of x plus y, and our lower limit here is how much? 0, and the upper limit is pi over 6. Okay, so let's write that down. Okay, and then I have dy. So notice this right here, that when we substitute y equals 0 for the lower limit, the whole product is going to be 0. So the only portion that we are dealing with is the portion for pi over 6. So what that becomes is, oh no, I'm sorry, I made a mistake, because we are substituting for x, not for y, and I was hoping of having a very easy ride, but that didn't happen. No problem, we can deal with these. Okay, so we got y sine x is how much here? Pi over 6. So x is pi over 6, and then we got plus y, and then minus. Now I'm going to write x as 0. Okay, I hope I didn't lose anybody in the process of wrongly substituting these here. So you got dy here now, right? Okay, now both of them will be done by integration by parts. So we can take these two together. Rather, what I'm thinking is this, that let's just write these two separately here. And so I'm still in double mind, and I decided to just do them separately, okay, which would not be that big a problem, okay. Or so in here you can see that we could have taken sine of pi over 6 plus y minus sine y as my dv portion, because here we are going to use the integration by parts, meaning that our udv is uv minus integral of v du, right? So let's just do this by employing it here. So this would be what? I am taking y as u and this portion as dv. Now we will write uv. So who is u? U is simply y. And again, this is dv. So v will be the antiderivative of sine of pi x plus y. So who is the antiderivative of sine? That's cosine, right? Actually, negative cosine. We'll pull up the negative sign here, and this thing will range from 0 to pi over 3. Okay, so let's just write this down here. Okay, ranges from 0 to pi over 3, right? And then we have a negative sign again. Okay, and then we are going to have what? The integral v du, which will be definite integral in here. So again, my v is negative cosine pi over 6 plus y. I could have made that positive already, but let me not just go too fast on myself. And here, this would be what? This would be simply dy. So what happens here? Here we get that what we get, this portion is pi over 3, right? So that is pi over 3, okay? And then again we have y equals how much? Pi over 3. And then when we subtract it, that negative sign combined with this negative would be 0. And since y is becoming 0 here, therefore the product would be 0, right? Now we have negative and negative becoming positive here. And then this antiderivative is what? That is simply sine of pi over 6 plus y, right? So we got sine of pi over 6 plus y, right? Okay, and my lower limit would be, or rather is 0, and the upper limit is how much? Pi over 6, right? Okay, no, sorry, pi over 3. Okay, so this, sorry about that, this value becomes how much then? Look right here, this is 0. Now, how much is pi over 6 plus pi over 3? That is pi over 2. And cosine of pi over 2 is 0. So this portion will be 0 as well. So let's just drop that right here. And what we get in this portion is, first we get pi over 3 here. Okay. All right. So we got pi over 3. And then minus, now I will substitute what? I'll substitute y as 0. So in this portion, we are substituting how much? 0. Now again, as we did before, this becomes pi over 2. So sine of pi over 2 is how much? That's a 1. Sine of pi over 6 is 1/2. So this portion becomes how much? 1/2. Now the other portion will be fairly routine, or exactly actually just repeating the same thing. That is, we have y sine y. So our uv will be what? I'm just copying and pasting for convenience. Let me just very quickly erase this. So, and so u is y. Now dv is sine y dy. So antiderivative would be negative cosine y, right? And then minus we again have, we are taking the integral from 0 to pi over 3, right? Okay, and then we have negative cosine y and then dy. So that becomes how much? First we get negative pi over 3, okay? And now we have cosine of pi over 3, right? So that's going to be how much? 1 over 2. We'll write that in the next step. And then when we go to the lower limit, this is 0. So the y value will be 0. So that's just going to be 0, right? And then plus antiderivative of cosine y is sine y. So what we got now is that we have the integral here. Oh, we don't have to write the integral there. Actually, let's just write the value because we know integral of cosine y is sine y, and the lower limit is 0. The upper limit is how much? Pi over 3, right? So what do we get here? So here we get, I think, cosine of pi over 3 is 1/2. Excuse me. So there I'm going to get pi over, I'm going to get, it's not 5, 6, right? And then plus sine pi over 3, okay? And how much is sine of pi over 3? That's simply square root of 3 over 2, right? Okay, so this is square root of 3 over 2, okay? And we may just finally write the values here because when we take this this integral over this rectangular domain, what that is, the first integral is this y sine of pi over 6 plus y, which we got as what? Which we got as 1/2, and then we have minus the integral of y sine y over the same interval. So that became how much? That became simply this negative pi over 6 plus square root of 3 over 2. We are almost done, or actually we are done, but let's just write it in the formal form, sorry, the final form rather. And negative, negative should be positive. So we got pi over 6 and then minus how much? Square root of 3 over 2. So that's the value of the desired integral. Let me know if you all have any questions. All right.